Hello, hi all. Welcome to our HSC Master of Data Science admission webinar. So today we are going to discuss with you our entrance exam, assignments from entrance exam. And let me present you Anton Gnatenko. So he will discuss with you some topics from entrance exam, assignments, and give you clues. So Anton, your word now.
Yeah, hello everyone, and thank you, Ksenia, for the introduction. I'll now switch my demonstration on. Here it is. You may now see the whiteboard that I will be using. And so we are going to solve 20 problems from the demonstration variant that we have. The complexity of the problems rises as the number rises. So I mean, the first 5 problems are very simple. The next 5 are more complex, and the last 5 are quite complicated. So you may be able to stay with us for the full length of the webinar. Don't quite when you see that the first couple of problems are too easy. The complexity will improve. Anyway, I will now just post in the chat, I think, where it is. I don't see it. Anyway, so you have a special option to ask questions in the questions and answers section. So if you have any questions during the solution of the problem, please post them there. And after I complete the solution, in between of solving 2 different problems, I will look there and answer the questions. I can answer, please mind that I can only answer the questions regarding problems and their solutions. And if you have any questions regarding, administrative issues and enrollment and exams, please mail to this email. Okay, so we start with the first problem where we are given a decimal number, 81, and we are asked to convert it to binary. So binary representation uses only ones and zeros to represent a number, and there are different ways to convert a number from decimal system to binary. For example, personally, I prefer this way. So I know that 81 is, let's think, what is the largest power of 2, which is less or equal than 81. It seems to be 64. And yeah, so 81 is 64 plus 16 plus 1. And these strange numbers are not so strange if you think of them, because 64 is 2 to the power of 6, and 16 is 2 to the power of 4, and 1 is 2 to the power of 0. So I kind of presented 81 as the sum of powers of 2. And now, just as a decimal representation is the representation that uses powers of 10, here using powers of 2, I can represent 81 in binary. So 81 as a decimal number is what? We have the 2 to the power of 6. Then we don't have in this sum 2 to the power of 5, so I write 0. We have 2 to the power of 4, so I write 1. We don't have 2 to the power of 3. We don't have 2 to the power of 2. We don't have 2 to the power of 1. And we have 2 to the power of 0. So this is the answer. This is a binary representation of the answer. And I'll just write it here. So please mind that in the testing system, you are asked to put to the field of answers the answer only. So you shouldn't write there, you shouldn't type something like 81 equals da-da-da. You should only write this sequence of ones and zeros. And you should always follow the instructions how to present your answers that are given in the task. So let me see if there are any questions. I don't see any questions in the questions and answers section. And I also don't see any in the chat. So I suppose that I can proceed. But anyway, if even after some time you have a question about some problem, you can always kind of ask a question. Don't hesitate. Oh, are calculators? No, calculators are not allowed. So you should do all the calculations by yourself using a pen and paper. But I think that in these tasks are specifically designed to, you know, to let you calculate without a calculator. So nothing really really hard to, you know, to find the for example, this numbers. So let's move to the next problem. Yeah, somebody is raising his hand now, but I'm afraid that the format is such that you need to ask a question by typing if you have one. Yeah. So our next problem is problem number 2, and it says that there is some number n which has, when divided by 6, a remainder equal to 5. So we know that n is 6 times something plus 5. Yes, then 5 is a remainder of n when divided by 6. We are asked to find the remainder of n when it is divided by 3. So we are asked to produce something like n is 3 times some number plus something, and this something should be less than 3. Well, let's proceed with our first equality. So we have n equals 6k plus 5, which means that it is 3 times 2k plus 5, which means it is 3 times 2k plus 3 plus 2, which equals this. So we see that actually when divided by 3, the remainder is 2. And this is the answer, quite simply. Are pen and papers allowed? Yes, I think so. And they should be, of course. Of course, you'll have actually pen and a pen and some piece of paper are the only things that are allowed on your desk when you're sitting at the exam. So you'll have a window where you have your problems and the fields for typing in your answers, and you'll have a pen and paper, and that's all. So I suppose we can move to the next problem, since there are no questions. And the next problem is this. So we have 4 plots of 4 lines. Each line is a plot of a function of this form, y equals k1 or k something times x plus some additional number. And we are asked to choose the correct option. So we have 4 these lines. Line A is this, yeah, and line B is this, line C, and line D. And so we are asked to find the correct option. Well, the general rule is that if I have 2 lines, and let me write them, for example, like ax plus b and y equals cx plus d. So this a, b, c, and d have nothing to do with this labels of lines. It's just a separate general rule I'm writing here. So if I have these two graphs, then these lines are perpendicular if and only if A times C equals -1. Okay? So this is a general rule. And we can apply this rule here. So let's see, K1 refers to line A and K2 refers to line B, which are not perpendicular. Hence, this is not the correct answer. K1, again, line A, K3, line C. Well, they are two not perpendicular, so there's not a correct answer. And while proceeding this way, you may see that there are only one pair of two perpendicular lines, namely B and D, I suppose. Yeah, so B and D, because this angle is straight. It's 90 degrees, or pi divided by 2. So, and K2 refers to this line, K4 refers to this line, hence their product must be equal to -1, and we have the answer E here. So I'll just circle it and also write it. Okay. Yeah, so now we turn back to binary. Here in the problem number 4, we have a binary equation, and we are asked just to solve it, to solve a binary equation of this 4. So I'll just rewrite it like this. I'll have 2x. I'll move this x around the equality here. And then in the other side, I will collect all the binary numbers. So I have this 1, 1, 0, 1, 0, 1, 1. I think I don't have enough space. Minus 1, 1, 0, 0, 1, 1, minus 1, 0, 1, 0. And this, when given in binary, must be equal to 2x. So I would prefer just to compute the number. So let's see, for example, you can do the calculation, for example, when writing these two numbers one above another, just in case to be fine with arithmetic. And here I take it, and here too, 1. Okay, so I got this result, and then I want to subtract the last number. Pum, pum, pum. 1, 1, and again 2, 1. 0, 1. So I hope I got this correct. Yeah, my calculations on the paper coincide with this. So now I have this. And what I should do is dividing by 2 both sides. Yeah, I can divide this side by 2, and then I want to divide this side by 2. But in binary, dividing by 2 is just removing the 0 in the end. Just like in the decimal system, when you divide by 10, you remove the last 0. So actually, the answer is this. It is 101, 1, 1. In binary, but I don't write any index here. And there is a question about how optimal or pretty should be the solution. Well, the answer is as follows. You are asked to produce an answer. Nobody checks your solutions, okay? You have a problem, you have a field for answer, then you solve the problem, you enter your answer, and well, if it is correct, you get a point. If it is false or incorrect, you don't get a point. And well, the way of how you solve it is not really assessed. And the thing is that since you don't have very much time, I would recommend you to solve the way you feel you'll solve it quicker and easier, okay? So when we move further to the problem number 5, which is about solving a system of equations. And again, there are different ways to solve it using linear algebra, I don't know, but there are nice and pretty ways to solve them, to solve systems of equations from, for example, I know them from my secondary school experience. I will just denote the first line as A and the second line as B. And I feel that I may want to, for example, maybe helpful to compute this sum. I'll have minus 2x plus 2y equals minus 2, which leads me to y minus x equals minus 1, which leads me to y equals x minus 1. Quite helpful. Then I can use this, I can substitute y in, for example, in the first equation by this x minus 1. So I'll have 5x minus 4 times x minus 1 equals 1, which is x plus 4 equals 1, which is x equals minus 3, and y equals then minus 4 from this. Yeah, and we were asked to find y, the value of y, so this is the only value we need to put in the answer. Yeah, so we have, imagine we have the field for the answer here, then I will only write minus 4, nothing else. No information on x is asked, hence I'm not providing it. Just the value of y. So moving further, the problem number 6 deals with a parabola of some unknown. So given by some unknown equation, we don't know these two coefficients. And we even don't see the full picture. So we have the graph, but somewhere there is its bottom, of which we don't know. We are asked to find the y coordinate of the bottom, of the vertex of the parabola. And well, in my opinion, one of the kind of most straightforward ways to do it is to, for example, find the coefficients a and b. And we actually have 2 points on the graph, namely this and this. I'll mark them with a and b, in which we exactly know the value of x and the value of y. Yeah. So we can substitute x and y in this equation by these pairs in order to find a and b. So we'll get 2 equations for 2 parameters, and then we'll find them easily. So we have, for the point a, 5 equals minus 2 squared is 4, plus a times minus 2, which is minus 2a, plus b. And we also have, for the point b, 5 equals So 5 equals 36, because 6 squared, yeah, plus 6a plus b. Well, so I maybe want to, to subtract from b, a from b, because I want this b to go away and I want this 5 to go away. When I subtract b from a, I get 0 equals 32 plus 8a, from which I immediately get a equals -4. And well, then I can, for example, substitute a with -4 in the first equation. And I get 5 equals 4 plus 8 plus b, which gives me b equals -7. So now I have the full equation. I write it with red here. Y equals x squared minus 4x minus 7. This is the equation of a parabola, which is given here. And well, I'm asked to find the y coordination of the vertex, yeah, which is actually the value of this expression when x is substituted with the x coordination of the vertex. And for a parabola of this form, the x coordination of the vertex is always, well, let me write it maybe the general rule here. So when I have a parabola of the form y equals, let's say, kx squared plus tx plus s, then the coordination of the vertex, the x coordinate of the vertex is minus t divided by 2k. And well, here we have the x coordination of the vertex minus a, which is 4, divided by 2k, which is 1 here. So it is 2. And well, it could be established from here, but well, we don't see it so rigorously. It's better to do that. Anyway, one could, of course, estimate it, because we see that, well, these are 2 lines on one here. These are 2 dots, 2 points on with same y coordinate. So we can just draw a line, break it in the middle, and find the x coordinate. But anyway, to find the y coordinate, we still need to find the coefficients. So now, the y coordinate is 2 squared, which is 4, minus 2 times 4, which is 8, and minus 7, which is minus 11. So this is the answer. Minus 11, okay? Yeah, so this problem is a little bit more complicated than the previous ones, because it deals with parabolas and, well, some rules from the, first grade calculus or something. So let's move further. And here we are again given a function and its plot. Now we have the full plot, fortunately, and we are asked the following. So they ask us what is the pre-image of the segment from -1 to 1 on the y-axis. So let me highlight this segment. So it's -1 to 1 on the y-axis. And we are asked to find the pre-image of this segment. So basically, what is meant is the pre-image of some set is a set of all values of x such that f of x is a number in this segment. So it is a set of all such x that f of x is in this segment. So let's find all such values of x. Well, what I would do, I would just, draw these two lines through the ends of the segment. And then I see that there are two parts of the graph, namely this and so this part and this part, which correspond to the values of f of x, which are greater than -1 and less than 1 or equal to the x. And well, what remains is just to find the corresponding values of x. So these blue parts of the plot correspond to this segment on the x-axis and this segment on the x-axis. So there are two segments, and both of them are parts of the answer. So we can't just choose, this answer, which is corresponding to this segment, because it would be only partially correct. There is another part of the answer here. And the correct answer is the union of these two segments, which is presented here. So our answer here is C. So I hope that it was clear. And since there are no questions, I will move further, but please don't hesitate to ask if you have questions. Problem number 8. Some guy called Chris wants to buy a TV which costs $625. And also he needs to pay an 8% as a tax, some way. Well, actually he has only 60% of the money and he wants to borrow the rest from his friend. So the question is how much he needs to borrow. Well, this problem is kind of simple if you understand the right order of, computing these percentages. So the thing is that initially he needed $625, but he also wants to pay a tax. Maybe he doesn't want to do it, but he has to. So we need to include this plus 8% of tax into the price. So I would multiply this number by one point. Let me use point, I think, since this is a webinar in English. A dot is more appropriate than a comma. Anyway, this product is the total amount of money he needs to pay. And then he possesses only 60% of this amount. So the remaining 40% of this amount will be borrowed. And we want to compute this 40% of this amount. So if you compute it, you can do it with pen and paper in a couple of minutes. And I just kind of did it already, so I will not repeat it. I'll just write an answer here, but it is kind of a basic arithmetic problem now. So the answer is this. $270 will be borrowed. The rest, Chris will pay by himself. There are some questions in chat. Yeah, no, not really. These are old ones. Okay, so let me move further to the problem number 9, which is again about plots. Plots are very popular with those who created the problems, I suppose. So we have two graphs, one which is on the left, so I believe this one, is a graph of the function y equals f of x. And let me just write it here above the graph. So this is y equals f of x. And the right one is a graph of another function. Let's keep it like this. G of x, which is actually f of x plus m plus n. So we are asked to find the values of m and n here. And well, there is a trap here, of course, because, well, sometimes people get stuck with, well, usually everyone understands that if I add something here, the value of function would increase, and if I subtract something positive here, the value of function would decrease, and since the value of function is represented by the y-axis, then, well, it is quite easy to understand that, for example, this point was at, let's see, at -1, and after adding some n, it went to -4. So something that was -1 when a number n was added became -4, which tells us that n is actually -3. It is -3 that you add to 1 to get -4. The problem may arise when you think about m, because we add m not kind of outside of the function, but inside. And here, well, positive and negative values affect the position of the plot somewhat, maybe counterintuitively, but if you think about it more, not very. So let's see what happens when we add something to x, to the value of the variable inside the brackets. Actually, when we add something positive, so let me write it. If the plot moves, well, sorry, I think I should write it in some more convenient way. So the plot of f of x plus m moves right if m is less than 0, if m is negative, and left if m is positive. So this is maybe a little bit counterintuitive, but think of it, if you think of the plot of the function as of some representation of a process, so if you think that, for example, this point was here when x was equal to 0, and at some point, for example, where x was equal to k, the plot was here. So if I now want to write a plot of f of x plus k, then the thing that happened here on this plot would happen at 0 on this plot, because I kind of made the things that happen in the future to happen k steps before. So here we see that the plot has moved one step left. Yeah, so it moved one step left. It was, oh, sorry, one step right, of course. It was here at the position of -1, and now this line is here at the position of 0. So it moved right, hence m is less than 0, and it moved by one cell, hence m is equals to -1. So one cell right means -1. So this is the answer. And we can try to find it here. Let's see. With the first option. The answer is A. So you can memorize this general rule. You can try to understand what underlies it by this explanation. On the exam, what you need is to apply it to get the answer, and that's all. As I said, your solutions are not assessed. So let me move to the problem number 10 now. And it deals with a function again, but not with a plot now. We are given a function and we are asked to find the value of its derivative when x equals 1. Well, first of all, I would just find the general form of its derivative, the representation, the functional representation. And to do that, well, I need to know some basic rules of how to differentiate different functions. For example, I have here polynomials which are differentiated like this. And I also have, let me include this in this rule. If I have some number k times x to the power of n, then the derivative looks like k times n times x to the power of n minus 1. The derivative of a constant is 0. And what else? Well, and actually, for example, something like this. Also equals. So you can differentiate it without thinking of b there. So let me compute it finally. So applying these rules, I have here 3 times x minus 1 squared. So this is this rule. Minus 4x. This is just this rule. And plus minus 3. And plus 0. Yeah, minus 3 is again this rule. Because I have this 3, k equals 3, n equals 1. 3 times 1 times x to the power of 0, which is 1. I get on the 3. Hope my Google Assistant didn't really say something. I saw it speaking. Anyway, yeah, plus 0 because there was a constant 1, and I just differentiated. Yes, there is a question. I can ask it right now. Will the recording be shared? Yes, of course it will be. The link to the recording will appear on the official page of the program, I suppose, in a couple of days or maybe in a week. So somewhere in the near future. Fine. Yeah, and so this is the derivative, and now I want to find its value when x equals to 1. And when x equals to 1, this term actually disappears. Then I substitute x with 1, I get minus 4, and minus 3, and plus 0, it's minus 7. And this is the value of the derivative of f of x at the point 1. So I found it. Okay. There is a question about the previous problem, so I will turn there for a minute. So the question is that, well, I said that if m is less than 0, then the graph should shift right. And our graph shifts to the left. Well, no, it shifts to the right. Remember, this is the original graph. This is the original graph. This is what we got. So our graph was here. Yes, this is the y-axis. Our graph was here, and then it shifted. So this point, which lied one cell before the y-axis, now lies on the y-axis. So the shift is to the right. Okay. Therefore, according to the general rule, m should be negative. Okay, so it is clear now. Thank you for the question. I hope it clarified everything also for the others who may had it. Okay, so this was the first 10 problems, and we now move to the next 10 problems. Yeah, we're given some expression which includes some unknown value, and we are asked to find this value. Well, looks scary, but I think we'll handle it. Let's just rewrite it somehow. So when you have this many powers and many numbers, it is sometimes useful. When you are on an exam, it's always useful, I suppose, to factorize these numbers using prime numbers, so to get a prime factorization. Just in order to find the common divisors of the both sides. So what I would do, I would first multiply both sides by 3, and I would also rewrite 6, 10, and 15 as the prime factorizations. And there is some hope that we'll find many common divisors. So let's see. X to the power of 11 times 2 to the power of 6 times 3 to the power of 6 equals 3. I multiplied both sides by 3, so 3 went here. 3 times 2 to the power of 6 times 5 to the power of 6 times 3 to the power of 16 times 5 to the power of 16. Well, now I can just divide both sides by 2 to the power of 6. And I can also divide both sides by 3 to the power of 6. This will give me 3 to the power of 11 here. So let me rewrite it. I have x to the power of 11 equals 3 to the power of 11 times 5 to the power of 22. Well, seems still a little bit scary, but not so scary as in the beginning. But now, well, maybe I want something like this. X to the power of 11 is a to the power of 11, because this will immediately give me that x equals a. Here I have 3 to the power of 11, but 5 to the power of 22. But, well, one may see that this 22 is just 11 multiplied by 2. So I can rewrite it like this and obtain what I wanted. Just one number for x. So according to this, x equals 75. And I'll just, because we have such a tradition, write the answer here. Yeah, x equals 75. So what we used here is factorization by primes, then just finding common divisors, and then using some properties of the powers, for example. Yeah, for example, here I used the property of the powers which is, let's say, y to the power of k to the power of s is just y to the power of k times s, for example. There are many different, many other properties of powers which you may want to know before you have your exam. Fine. There's still no questions. Oh, all words below the graphs are hidden. That's maybe about this problem number 8. Oh, number 9. Okay, I'll try to write higher. I never had this problem before on previous webinars, so I didn't know. I hope that you see the contents of the slides fully now. If not, please tell me, but I think I can leave them up right now a little bit. Let me first write the problem statement. So the problem number 12 is about a robot which lives in a maze drawn here, and it also has a block diagram, which represent an algorithm for the robot. We know the starting position of the robot here, and we want to know where will it be after executing the program given by this scheme. Okay, so I'll now, I think, lift everything up so that everyone can see everything, but I'll hide the problem statement. And if you still don't see something, please write it in the chat. There's also a phrase in the chat that someone didn't get this point, but if you can clarify which point you mean, I can re-explain it again. Okay, so now I will continue solving the problem number 12. So let's see what happens. At first, robot checks if it can move down, and if yes, it moves down and then repeats everything. So we have this very first loop here, which means that the robot would move down while possible. So first of all, it moves here. Then when it's not able to move down, we proceed here in the diagram, and we check if the robot is able to move up. And well, it can. Hence we go by this branch. We move up one step. And if it is able to move right, which is again true, we move right once, and then the very same question, we move right the second time. After performing it, we return back to the beginning, where, as we remember, what we first do is we move down while possible, then move up one step by this operation, and then move right twice, bum, bum, and then again go to the beginning. At the beginning, we again go down while possible, then go up, and then here we ask if we're able to move right, and we see that we cannot, so we stop the execution. And this is the cell where we are stuck. So this is D5, and our answer, maybe it is not visible here. I'll write the answer higher. Our answer is D5. And what is essential is the format of the answer. I would remind you that in this problem statement, it is said that here, that we're asked to give an answer as a pair of letters like this. Is a pair of a letter and a number like this before. So, so be careful and do as asked. Enter your answer like this, D5, not 5D, not something else, not cell 5D or cell D5, just these two symbols. Okay. Well, there is a question about the books which are suitable for preparation. Well, I suppose that, of course, the books that are mentioned on the website of the program should be indeed enough. Just because, well, I suppose that the creators of the problems, well, relied on these books when they made them. So I would say that yes, but you may want to also email this question to the program coordinators using the email I've given. So they will ask those who really created the problems. But I suppose that, of course, the books that are given on the web page should cover all the material. Okay. So the next problem is a problem number 13, which is as follows. So we have two operations. This is a question about operations with numbers. We have two operations of dealing with numbers. One is multiplying the given number by 2, and another is crossing out the last digit of a number, but keep in mind that it is applicable only when the number is at least 2 digits. Well, actually, anyway, the operation is stated like this, so we'll use it like this. So we are asked what is the minimal number of steps to get from 50 to get to 50 from 8. So we want to get from 8 to 50 using operations A and B in some order, repeating them. And we are asked to use the minimum number of operations. Well, there are different, well, actually, you can first find a solution and then prove that it is a minimal, that it is a minimal solution. Yeah, that's you can solve the problem using smaller number of steps. But in this particular question, I prefer to find the solution simultaneously with proving that it is optimal. So we start with 8. Yeah, and there are 2 ways to proceed. There's only one way to proceed actually, because 8 is a 1-digit number, so we cannot apply the operation B. We only can apply the operation A to get 16. And now we have 2 ways to proceed, because 16 has 2 digits, and we can either double it using operation A, or we can cross out the last digit using operation B. But now let's see what happens. If we go to the upper branch and get 1, then we'll have only one way to proceed. Yeah, only operation A is applicable. And again, only operation A is applicable. And again, only operation A is applicable. And we get back to 8. So if we want to solve the problem, if we want to get to 50 using a minimal number of steps, this particular branch is not what we want. We don't want to go here, okay? So we want to go along this branch. When we have 32, we again have 2 options. Either we can multiply it by 2 or remove the last digit. For 64, we also have 2 options. And for this 128, we also have 2 options. Now, one may observe that for these 2 options, there are only actually 2 ways to proceed. Only one way to proceed for each. Yeah, we cannot cross out the last digit of 3 because it has only 1 digit. So this operation A is here and B is here. and here A's again. But anyway how we go, so either we apply A here and then B, or B and then A, we arrive to 6, and somehow any try to go by operation B somewhere here will lead us to 12 only. And well, here one may think what to do next, but it is kind of easy to see that from 256, we can very quickly get to 50. Yeah, we can apply operation B to obtain 25, and then apply operation A to obtain 50. So there are 2 steps from here. And overall, we have 1, 2, 3, 4, 5, 6, 7 steps. But what about this option? Until this 12, we also have 1, 2, 3, 4, 5. So the question is, can we get from 12 to 50 using less than 2 options, less than 2 steps? Well, no. If we use operation A, we get 24. If we use operation B, we get this unlucky one that we have already considered here. So no chain of 6 steps leads us to 50, no chain of 6 steps. And there is a chain of 7 steps which leads us to 50. So the answer, what is the length of the optimal solution, is 7. Oh my God. Answer 7. Fine. There is another question. There is no need. Yeah. Wait. I'll start from the beginning. So the first question is how long does the exam last? I'll check it. I think I have the. Well, I don't have this information here. It is surely written on the web page, so I have seen it there. I suppose that I would not pronounce the answer that I remember because I'm afraid that it may be wrong. So please go to the web page. There is a section called preparation something, and there is something written in bold, and it says that, you know, the exam lasts for minutes. So please see it there. I'm not aware of the passing score, but as I remember, as I know well, the passing score depends on, you know, the performance of all those who take the exam. So it is not like we have some minimal score and everyone who achieves it enrolls. No, we first give you problems, you solve them, then we have a list of the results, then we, you know, sort the list from the maximum result to the minimum, and we take, for example, if we have 20 places, I don't remember how much, but if we have 20 places, then 20 best students are enrolled to the program. So we don't have, you know, a particular minimal score strictly set. And maybe you want to learn the last year passing score, but this is a question that should be asked, I think, not to me. You may want to write to the email that I've given, and that which is somewhere here in the chat also. This mds at hse.ru. I think that they can provide the answer. No, there is no need for a strict proof because, well, the only thing we want from you is the answer. But, well, for example, for me, it seems safe, and I feel safe when I have a proof that my answer is correct. Yeah, because, well, if I, for example, imagine that I found this chain of operations, and I know that there are some chain of 7 operations. that leads me to 50 from 8. But how can I be sure that the answer is correct? How can I be sure that I can't use 6 operations? Well, so this proof is kind of a part of solution that I do on my paper. But it helps me to be sure that the answer is correct. And if you have time, I think it's worth doing. Yeah, thank you. Somebody have written here in the as a question, but it is actually it's an answer that the length of the exam is 90 minutes. But well, it's still better that everyone goes to the official page and sees it yourself. Yeah, and there's actually a link. I'll post this link to the chat. Thank you very much, Alexei, for it. I'll post it to the chat so that you can find it. You can find all the information there. Yeah, so this was the problem number 13, sorry. The problem number 14 is more like a high school problem. We are asked to solve the inequality. So I will do it now. Let's see. X squared plus 2 divided by x squared minus 4. Well, why do I rewrite it? I'll just do this. Minus 1 is less or equal than 0. Well, let's reorder it. Let's just, maybe I will, because there is not so much space on the slide, I'll just use the rubber. I will represent 1 as this fraction. I will just do the calculations. So it's x squared, well, let me write it, x squared plus 2 minus x squared plus 4. So it leads me to 6 in the 6 above, and x squared minus 4 in the bottom. But I remember a formula which says that this is the difference of 2 squares, so I can rewrite it like this. And I want to know when this expression is less or equal than 0. Well, actually, it's never equals 0. Never equals 0, but it's sometimes less than 0. So let's find when. So I prefer to draw here, and I draw the line for x. And well, the numerator, which is 6, is a constant. It is always 6. So the real, the real play here is the denominator. And the denominator has 2 points when it changes its sign. We are only interested in the sign here because we are asked whether this fraction is positive or negative. So there are 2 points, namely -2 and 2. And when we go through this point from left to right, one of the factors in the denominator changes its sign. Yes, so this x plus 2 was negative here, but it becomes positive here. And x minus 2 was negative here, but it becomes positive here. Please note that the denominator is actually not defined. The denominator is defined, but the fraction is not defined at this point, because you'll need to divide by 0 if you want to evaluate the value of the fraction here at this point or at this point. So these are points where the fraction is not defined. We cannot include them in the answer. So one may already say that all these kinds of square brackets lead us to a wrong answer. Anyway, let's see. So we have these 3 segments. And as I said, for example, here, here this factor is negative and this factor is positive. So their product is negative, and 6 divided by something negative is also a negative number. So here, the total value of the fraction is negative, and hence, since this is the point of the change in the sign of only one factor, here the fraction is positive, and here it is also positive. So our answer is actually this interval excluding the endpoint, which is written like this in mathematics. Hence, we know that the answer is C. Okay. So there is another question about the same. Can we assume that the exam problems will have the same structure as the sequence of problems that we are analyzing now? Well, it depends on what do you mean by the structure. They should be they should be similar, yeah? So the problems on the exam should be similar to this variant. And by this, I mean that they should be on similar topics, but maybe not exactly on these topics. They may be on any topics that I mentioned on the website, of similar complexity and of similar, question type. So you will be given questions where you need to choose one answer from the given sequence, or to type a short answer. Yeah, which may be a number, or for example, a sequence of a letter in the number, as in the problem with the robot, or something. So yeah, we're analyzing these problems exactly because they're similar to those which will appear on the exam, but nobody says that they will be exactly the same. So I hope that I answered this question. So let's move further. Problem number 15 asks about an arithmetic progression. And well, arithmetic progression is a sequence of the form a plus d, a plus 2d, and down further, where a is the first term and d is the common difference of the progression. So if we want to, for example, let's denote the eth member, the eth term of the progression as bi. So b sub I is a plus, sorry, I minus 1 times d. Yeah, because b sub 1 is just a, b sub 2 is a plus d, b sub 3 is a plus 2d, and so forth. So we are given that the 9th term, so b9, is 3, and we are asked to find the sum of the first 17 terms. So we are asked to find b1 plus b2 plus plus b17. So first of all, let's rewrite this 3 as b9, which is a plus 7d. Yeah. Sorry, not 7 really. 8d. Yeah, I equals 9, therefore I minus 1 equals 8. So now let's rewrite this sum. Well, so we have, let me use some mathematical notation. It is sum by I from 1 to 17 of bi, and then I can use the formula that I have for bi, which is a plus I minus 1 d And then, well, you can see that the parameter I, which we are summing by, appears only here. So I can, first of all, there's A that is added 17 times from 1 to 17. So it's just 17 times A plus D times sum of this. Well, maybe this notation scares you. Don't worry, I will just maybe rewrite it. I hope that it's still seen here. Please let me know in the chat if it's too low. So it's 17A plus D times 1 plus 2 plus 3 plus plus I minus 1. Plus, sorry, I plus, I'm writing something wrong. So let's see. We are computing a sum from 1 to 17 of I minus 1. So when I equals 1, this is 0. When I equals 2, this is 1. When I equals 17, it's 16. Now, there are different ways to compute this sum. Of course, you can just do it by hand. It's 1 plus 2 plus 3 plus 4, plus 16. But there is also a very convenient formula to compute such kind of sums. So general rule is as follows. If we have, for example, to compute a sum of the first n natural numbers, then what can we do? We can first, maybe it's a little bit misguiding, but still, we may first want to compute this very sum, but written down twice. If we have this sum, then it is very easy to see that it is actually a sum of values which all are equal to n plus 1. And there are exactly n of these values. So the value of this big sum is n times n plus 1. And since we have our sum here 2 times, then the real value of this sum will be twice less, which is n times n plus 1 divided by 2. So this is the formula for computing this kind of sums. Here we have 1 plus plus 16. So we have 17a plus, let's see, n equals 16. So it's 16 times 17, sorry, 16 times 17 divided by 2. And well, where can I rewrite it? Let me free some space for myself here. I'll just write it like, again, B9 is 3, and it is A plus 8D. While here we have the sum that we want to find, S, equals 17 times A plus, oh, there's also D here that I have forgotten, yeah, times 16 over 2D, which is basically 17 times A plus 8D. So we have found that, surprisingly, well, of course it was intended to, that our sum that we want to find is just 17 multiplied by this value, which is known, it is 3. So if I continue, I know that it's 17 times 3, which is what, 30 plus 28, 51. And this is the answer, 51. So we use this, of course, we could do the calculation by hand, but we use this famous formula obtained by Gauss, one of the best mathematicians of all times, when he was a primary school student. Yeah, there is a question of math problems book to prepare for the exam. Well, that's a complicated question because we have very different types of problems. They are all kind of simple. I mean, they use kind of simple material. They may be not so simple when you try to solve them, but this material is kind of a collection of different courses, like some from discrete mathematics, some from programming, some from calculus, some from algebra. So I don't know if there exists a book which, you know, kind of is comprehensive enough to include all this material. I suppose that there are recommendations, and they were also mentioned today, that there are recommendations on the official web page. So I hope that you can find some references there. And if no, please, you can write to the email and ask them. Yeah, I suppose that's the best answer I can give. Fine. What we have else? We have 5 more problems. Got to be quick. So let's see. The problem number 16 is a textual problem, which tells us something about jaw. And well, if you have a textual problem on the exam, you will possibly be required to write some equations using the text and then solve them. So let's see. Some Joe wants to become a president of the student council. So he has 37 supporters, and he can give speeches which lets them to obtain 25 more supporters each. But after each speech, 3 supporters would, well, quit him, would stop supporting him. So we're asked how many speeches he ought to give to obtain at least 350 supporters. So let's just write down what I have just read. So he has 37 supporters now. He wants 350 supporters, and he gives speeches. Let's say that he given S speeches. So S is number of speeches, okay? Speeches. It's like this. Plus S times what? How many supporters he gains per speech? So he gains 25 supporters and loses 3. Seems like that. So we have that. Oh, and we want to get maybe not exactly 350, but at least 350. This is important. So let's see. We have 37 plus 22S must be greater than or greater or equal than 350, which means 22S must be greater or equal than 313, which means that S must be greater or equal, let me write it here, and 313 divided by 22, which is, I performed the calculation, but you can always check it with a pen and paper, which equals 14 and, well, and something, okay? Well, so we have S should be not less than this value, but since S is a natural number, yeah, nobody can give a half of a speech, or at least not in this problem. A natural number can be greater or equal than this value only if it is greater or equal than 15. So from these 2 assertions, we get S greater or equal than 15, which means that the minimal number is 15. Okay, so 15 is the answer. this kind of problem. Well, there are two main points: to properly write the equality or the inequality which represents what is given by text here, and also to remember that when dealing with natural numbers, you need to switch from the fractions to the closest integer and to the integer closest from the right side. Yeah, if we want s to be greater or equal than this fraction, well, then we want it to be greater or equal than 15, not than 14, for example. 14 is not enough. Okay, what's next? Problem number 17. How many ways are there to write down numbers 1 and 2 in such a way that the sum of all those numbers equals 9? Well, just a moment. I think that I need to drink some water, of course. Otherwise, I will not be able to speak. Sorry. Okay. So, yeah, how do we represent 9 with a sequence of 2s and 1s? We are given some examples, and we need to compute all these possible ways. So this is a problem in combinatorics. So let's see, how many 2s can be there? So the question that I want to ask, how many 2s we use? And when, well, there are different possibilities. We can use no 2s. Let me write like this, no 2s. Then the only way to obtain 9 is to use 1s, and there is only way to get it, to do it, just, 9 1s in a row. So it's one way. The other possibility is to use 1, 2. The other to use 2 2s, and also 3 2s, and 4 2s. We can't use 5 2s because if we have 5 2s, then, well, what we have is at least 10. Yeah, 5 2s give us at least 10, and this is more than 9. So these 5 possibilities are the only ones we have. Let's see, if we have 1 2, then we have something like this: 6 1s, 7 1s actually, yeah, and a 2. But of course it can be rearranged. For example, the very same 9 will be obtained if I rearrange the numbers like this. So how many different ways to place this are there? Well, we have 7 positions, don't we? Oh, we have 8 positions actually. 8 positions, and we can place our 2 on any of them. So there are 8 ways to choose the position for 2. 8 ways to choose the position for 2. And the other positions will necessarily be filled with 1s. So actually there are just 8 possibilities to rearrange this sequence. So we have 8 ways here, 1 way here, or what I'm doing. Anyway, 1 way here, 8 ways here. Very similarly, if we have 4 2s, then we have only 1 actually, and therefore 5 positions in which we choose the position for 1, and the other positions are filled with 2s. So one can go in either of these 5 positions. The other will be filled with 2s. So there are 5 ways to rearrange this sequence. It is a little bit harder with these 2 options because we have, well, so if we have 2 2s, then we have what, 7 positions. And if we have 3 2s, then we have 6 positions. And well, the number of ways to rearrange, for example, this sequence is the number of ways to choose 2 positions from 7. Yeah. So we have 7 positions, and we want to choose 2 positions from them. So in general, if you have n elements and want to choose k elements, k of them, then the number of options you have is denoted like this, or in Russian tradition like this, and can be computed using this formula, where factorial is just the product of all numbers from 1 to n. So this is a kind of a basic combinatorial formula. And here I want to choose from 7 positions the 2 which correspond to 2s. So I want to compute this number from 7 choose 2, which is 7 factorial over 2 factorial times 5 factorial, which is actually 7 times 6 over 2, which is 21. So I have 21 options here. And also, let me move upper. Here I want to choose from 6 positions, 3 positions for 2s, for example, or 3 positions for 1s. It doesn't matter. But it is 6 factorial times 3 over 3 factorial times 3 factorial, which is 4 times 5 times 6 over 2 times 3, which is, okay, this just, like I can cross them out. So this is 20. So let me write it here. Here we have 20 ways. Here we have 21 ways. And the total amount of ways is just the sum. I'll write the answer at the bottom, but I will also say it in case you don't see it there. So it is 1 plus 8 plus 20 plus 21 plus 5, which is 1 plus 8 plus 21 is 30. 30 plus 20 is 50, yeah, and plus 5 is 25, correct. Oh, what I'm studying is 55. So we have 55 ways in total. The answer is 55. So I divided the kind of all ways into the groups. Defined by the number of 2s used in each sequence. And then I computed the number of corresponding sequences for each group. And then I just summed up. That is what I did. So this may seem as a, so actually it's kind of a simple combinatorics, but it's kind of, you know, so there's much to count and much to write. So it may seem scary. So if you have any questions, please answer them. Please ask them. Are the previous sample exam papers available? Yes, the previous sample papers and even I suppose the previous real papers. I may be mistaken on that, but the previous sample papers are for sure available on the website. For example, you can follow the link that I posted in the chat, thanks to Alexei. And I think you'll be able to find the papers there. Fine. Let's move to the next problem. It's the problem number 18. And here we have a system of conditions or system of, constraints. And what we want is we want to something like to do a constraint satisfaction program. We want to find the maximal integer such that at most one of the conditions is violated. Yeah, so we may violate one condition, but not more. And we want to find the maximal integer with this property. So I would like to simplify, I think, this condition. Strange, maybe do a strange task, but so I want to simplify it like this. So if 2x plus 1 is greater than 11, it just means that x is greater than 5. And also here, 2x is greater than minus 2. So x is greater than minus 1. And also here, x is less or equal than 28 divided by 2 is 14. And greater or equal than 23 divided by 2, it is 11 and a half, yeah? Something like this. And also here, x is less than 14. Okay. Yeah, so I simplified the conditions. Now let me take a close look at them. Well, so we have the only upper bound for x in these two conditions. For these two conditions, there is no upper bound, and we are looking for a maximal integer, so we are looking actually for the upper bounds. So what if x is greater than 14? Well, then this condition would be violated, and also this condition would be violated. So let me denote them with letters. Then both C and D are false. So, well, x cannot be greater than 14 because we are allowed to violate only one condition, not more. So it can be greater than 14, but what if it equals 14? The next kind of, the maximal possible answer then, or the maximal still possible answer. Yeah, we know that x cannot be greater than 14, but maybe it can be exactly 14. So let's see. Then A, B, and C are true. So only D is violated. Only D is false. So that is okay. We're allowed to falsify one condition. And well, it's a maximum possible such value, because if we have a bigger value, then we violate two conditions. So the maximal possible is this. And the answer is 14. So here's just kind of, a small portion of logical reasoning plus some portion of arithmetic. Please be very careful here. For some reasons, I want you to perform some arithmetical tasks before, using your logic. And, well, not very good idea for me, but still. You need to do that, so please be careful. If we will have some similar problem on the examinatives. Not very good to, to be good with logic, but have a mistake and thus spoil the full problem. Fine. Our next problem is this one. And to be honest, I spent 20 minutes yesterday to solve it, which is not really good because you have 20 problems for 90 minutes. So you don't have much time for any problem, for each problem, or for one problem, because not enough time per problem. Maybe that is the correct phrase finally. And so please keep the time in mind. If you think that you are stuck, it's maybe a good idea to just move to the next problem. Okay, don't sit more than some short time on one problem, because all problems are equal in their weights. And if you have some time in the end, you can always return and solve some problems you skipped. But it is a bad idea to try to solve one problem and run out of time, because you could have solved, for example, 3 more problems instead. Anyway, for this system of equations, which you can actually add that x is greater than 0 here, a good thing to do is to, well, let me denote this, is to see that, well, if these two fractions are multiplied, then you obtain x squared times y squared, which is xy squared, which is something which looks like just xy, x times y. So it is a good idea to multiply these two lines, and then you will obtain something like this. This is kind of a thing that you can get by as inspiration, after some time of looking at the problem. It maybe comes with the experience, to get the idea to multiply, for example, the two lines. But if you're lucky, you can, I think, come up with this idea fairly quickly to solve the problem in the exam. Okay, so let's see what we get. So here we get x squared times y squared. And here we get x squared times y squared plus 18x times y minus 144. And crossing out the same values leads us to just x squared, so 18 x squared xy equals 144, which is just xy equals 8. Well, then you can, for example, have this expression for x from here and just substitute it to the, for example, to the first equation. Okay, so xy is 8 plus 24 equals x squared over y, x cubed over y, which means that x cubed is, sorry, I'm moving the windows around my screen. X cubed is 32 times y, okay? So now I will combine these two equations, and I'll possibly do it here. Sorry for the chaotic use of the whiteboard. Okay, so I have 32y equals x squared, and x equals 8 over y. So it's 8 squared, or sorry, not squared, but cubed. So it's y cubed, and 8 is 2 to the power of 3. When cubed, it's 2 to the power of 9. So it's 512. Maybe I didn't need to compute it, but anyway. This leads to y to the power of 4 is 2 to the power of 9 divided by 2 to the power of 5, which is 2 to the power of 4, which is 16. Therefore, y is either 2 or minus 2, which means x is either 8 divided by 2, 4, or minus 4. But since we have that x is greater than 0 in the problem statement, then we opt for this option. And answer is 4. Okay. So we have one last problem given. If you don't have any questions, but if you have some, still please write them in the chat or in the questions and answer section. And I will move to the problem number 20, which is again a textual problem, and it is about rabbits. So there is a wizard's hat, maybe looking like this, and there are 100 rabbits inside. So these rabbits are black, white, and gray. And let's say that X, for example, is the amount of black rabbits, and Y is the amount of white rabbits, and Z is the amount of gray rabbits. Then we know that X plus Y plus Z equals 100. And we also know that if we pull any 81 rabbits, then we certainly would get at least 3 rabbits of different colors. So we'll get rabbits of all different colors, all 3, in this 81 group, in this group of 81. We are asked to find the smallest number of rabbits that we need to pull out of the hat to guarantee that we will have at least 2 colors. Okay? So what does actually this statement tells us? It says that if we pull any 81, there will be rabbits of all 3 different colors. What does it mean? It means that 81 is greater, for example, than X plus Y. Because if 81 was equal X plus Y, then, for example, we could pull out these 81 rabbits and they would be only black and white. There would be such a possibility, but we are guaranteed that it is impossible. Hence, 81 is greater than X plus Y. It is always also greater than Y plus Z, and also greater than X plus Z. So we have these 3 inequalities, but what I want to do is I want to make another assumption without loss of generality. We don't know how these 3 numbers correspond to each other, but let's assume that X is not less than Y and Y is not less than Z. This is an easy way to proceed, and it is also kind of legal because, well, if it is not like that, then we can just rename the colors in order to obtain this situation. But it will be much easier to reason using this assumption. So if we have this assumption, then what we have is only that X plus Y is less than 81. Because, well, X plus Y is the maximal possible sum of a pair. And this is, and then to write this is enough to represent what is said. I'll just maybe, since the rabbits are counted in natural numbers, we write it like this. So this is the information we're given. Okay, we are now asked to estimate how many rabbits we want to pull. We need to pull to out to guarantee that there would never be, you know, a group of the same color, so that we will obtain at least 2 rabbits of different colors in the group we pull out. And well, what can happen? We can if we pull out only kind of, for example, 50 rabbits, what would happen? May it be so that X is, for example, greater or equal than 50. If it is possible, then 50 is not enough. Or is it possible that Z is greater or equal than 50? If this is possible, it is still not enough. But since X is the greatest of these 3 numbers, we actually want to pose questions only about X. So actually, what we need is is to find the upper bound on X. For example, if we find that X is never greater than, cannot be greater than 50, then 51 rabbits is enough. If the upper bound, the best upper bound is 40, then 41 rabbits is enough. I mean, 51 is enough too, but we are asked to find the smallest number of rabbits that we need to pull out. So let's find the best upper bound for X using this information. What I would do, I think that I would subtract. So let's make our notation here again. I would subtract C from B so that I will get some bound for Z. Because X and Y would go away, I'll have Z is greater or equal than 20. Very well. Having this and having A also leads us to the conclusion that, well, Y is also not less than 20, because Y is not less than Z. But then from B, we have that X plus Y plus Z is 100, but it also is not less than X plus 40. Therefore, X is not less than 60. Not greater than 60. The correct phrase is, it is not greater than 60. Fine. Is it the optimal upper bound? Namely, is there a situation when X is exactly 60? Or maybe we can reduce the upper bound some more. Well, there is such situation. So imagine that Z is equals 20, Y equals 20, X equals 60. Then X plus Y equals 80. And so the statement is not violated, it is still true. So it is possible that X equals 60. And I'll write it here, and I hope you see it, but it will remain on the blackboard. It is possible that X equals 60. But this means that 60, this means that given the information from the statement, if we want to guarantee that in the group we pull out there are at least two different colors presented, we need to pull at least 61 rabbit, because if we pull 60, it is possible that they will all be black, for example. So the answer here is 61. And this is a kind of problem which is, I would say, much more complicated than the problems that we had, as we met in the beginning, because it has to do with equations, with combining equations. It has to do with logic and reasoning, and also with some, discrete arithmetic, because I rewritten this 81 with 80 here, made the equality sign not strict. So this is a problem for which you may need more time than for the problems in the beginning. So please, so maybe it is a good idea to, to learn how to solve the simple problems quickly, so that you will have enough time for the problems in the end. But please remember that all problems are equal in their weight. So this problem, although it is much harder, gives you just the same 1 point as the first problem. Okay, so keep that in mind. I think I have finished. I will just look for some more questions. Yeah, about the application process, I cannot give any answers. I just don't have this, this right, because I don't know much about that. So please refer to the email, and there also must be a webinar. Maybe it already happened, and maybe it will happen in the future. But even if it's happened, there should be a recording online on the organizational questions. Okay. Yeah, about the exam. This I think I can tell. So the exam will be held online. You will need a computer with a webcam. Yes. You will have a proctor there. So proctoring is a special system where you have some person somewhere there on the other side of the webcam who is watching you. And you also write your answers, and you use a special kind of software, or it's just a website, but nonetheless, the only thing that can be open on your computer during the exam is this window with the problems. So there is not much possibility to cheat, and I ask you not to do that. You are allowed to have a pen and paper. You're not allowed to use a calculator, and you're not allowed to use any, other equipment. The proctor may ask you to show your workspace, to take your webcam and to, kind of move it around a little bit to show that you have a clear workspace with just a pen and paper and yourself there. And then you have 90 minutes to solve the problem and to enter your answers to the answer fields. I hope that I answered the question, but if you have something more to ask, please let me know. Will there be another webinar? Well, do you mean the webinar on solving problems? I don't think so, because the exams are quite close. But there are a couple of webinars I've given before, and there are for the previous exams, and there must be the recordings posted on the websites online. Okay, so you may refer to them. According to the exam instructions, so about well, I think that your login and password are not accepted on the examination page because the exam haven't started. I suppose that the organizers will send you the relevant, login and password by the date of the exam. That is how things should be. If you're worried, please ask. I can again only refer you to the email I've given. Let me switch to the first slide. It's written there. Here it's MDS, which is Master of Data Science at hse.ru, and they should know all the answers for the organizational questions. Well, the bell curve approach is of course applicable, but unfortunately I don't have the data, so I just don't know. I'm sorry. And again, maybe the people under this email, well, they certainly have the data. Will they be willing to give the answer to this question? I don't know, but you may try. About the proctoring software, will you need to install it? Again, I don't know. Well, yeah, I just don't know. Please write to the email. Unfortunately, I can't really answer any questions out of the sample variant we're considering here. Where can we find the recording of the webinar? Well, it will be posted. First of all, it should be emailed to all those registered for the exam. So it will be emailed, I think, and also this whiteboard will be emailed to you. So yeah, and also the link for the previous webinar is posted online on the page that I just put in the chat. This is the last message in the chat. It's hse.ru/n/ma/mds/requirements. It must be there or somewhere near. So on the web page of the program, it should be, but it also will be emailed to you. Well, so there are no more questions. I hope that this webinar helped you at least a little bit. Yeah, okay, let me, okay, look, the whiteboard will be emailed, so I may very quickly just slide these problems one by one, but don't worry, as I said, the recording and also the whiteboard will be posted online, so there's no need to actually worry about if you have written down something incorrectly. You will always find them online. So maybe this just, I'm sorry, but yeah, I think I also need to go now because it's already 2 hours of the webinar. Yes, thank you very much for coming. We will be very glad to see you on the program. I wish you a good luck with your exams. I think that the problems are such that you always can solve them. Just keep calm and practice. And on the exam day, well, mind your time and you'll be okay. Okay, thank you very much. And I think I will stop this webinar now. See you on the program.